In this session, we're going to look at lessons 62 through 64. In lesson 62, we're going to look at two concepts. The first one is called abstract coefficients. And it is this one right here. It's abstract, so there's no actual numbers in here, it's just letters. And we're solving for y. Now this is no different than this problem right here we're solving for y. The only difference is we have numbers here in front of the x and y. And here we have letters in front of the x and y, but you still solve it the same way. So in order to solve for y, I'm going to eliminate x. In order to eliminate x, I'm going to multiply this top one by negative d and this bottom one by a. Whenever we do that, we're going to get negative dax plus, negative dby equals negative dc. Here we get positive dax and we get positive eay equals af. And when you add these together, these will cancel. That was the whole point of what we were doing. So then we get eay minus dby equals af minus dc. Now we're going to factor a y out, and we get ea minus db equals af minus dc. Divide both sides by ea minus db, ea minus db. That cancels, so you get y equals af minus dc all over ea minus db. That is solving for y, and all we did was eliminate the x terms and get y by itself. That is all there is to these. It's nothing new to teach you. It's just to be able to kind of weed through the abstractness of this x and y system of equations type problem. The second type on lesson 62 is called linear variation, and it's where things vary linearly. And if you remember, linear equation is y equals mx plus b. We've done this 1,000 times. Well, in this one, they say that the cost varies linearly to the workers that work there. The cost of the business is a linear equation, and so instead of y equals mx plus b, we do cost equals m workers plus b. So we're still solving for the slope and the y-intercept, just like we always did. Remember, m was the slope, and b was the y-intercept, and you plugged in x and y for that. Well, we know x and y, or c and w. We know that it costs us $15,000 to hire 10 employees, and that was what they gave us in this particular problem. They said 10 workers cost $15,000. They said that 20 workers cost 20 workers cost $20,000. And then they said, how much would 30 workers cost? Well, you can obviously see that one. It's pretty easy, but you can't always just see the answer like you can in this one. Let's learn how to solve for this. Easiest way to do this is to multiply this top equation by a negative 1. When you do that, the b's will cancel. You will get 10m, because that is the slope, equals 5,000, divide by 10, 500 equals m. So our slope is c equals 500 workers plus our y-intercept. So we got to solve for b. Well, we could plug in the numbers we've already had to solve for b. The cost was 15,000 for 500 times 10. What would our b be? So it would be 5,000, 15,000 on this side, subtract 5,000. When you do that, you get b equals 10,000. So b is 10,000. Now in order to solve for this, you're simply going to plug in your 30 workers right in here for W. So 30 times 500, which we know would be 15,000, plus 10,000, that will be 25,000 is our answer. That's what they wanted to know, was how much would 30 workers cost. And you could see it, the way we lined it up, 10, 20, 30 was going to be 15, 20, 25. But in the future, the numbers won't be so easy to be able to see that, and so you learn how to solve. In lesson 63, it's one concept, and it's completing the square in order to draw a circle. So that's what we're going to do. Complete the square in order to draw a circle. So x squared plus 4x. So we're going to get ready to complete the square. Y squared minus 6y. And then we're going to bring the 6 to the other side. It becomes negative 6. Now, in order to complete the square, remember you divide the middle term by 2. So 4 divided by 2 would be 2. And then you square it. So 4 divided by 2 is 2. 2 squared is 4. Now, if you add 4 to one side, you have to add 4 to the other side. Because if you brought this back, it would be negative and they would cancel out. It would be 4 minus 4 is 0. You balance it. So how are we legally able to add the 4 in there? The way we were legally able to add the 4 in there was we put 4 on the other side. Same thing here. Complete the square. So divide by 2. 6 divided by 2 is 3. And square it. So plus 9 plus 9. Now, when we did that, we get a perfect square, which is x plus 2 squared plus y minus 3 squared equals, and on the other side, you end up with 13 minus 6. 13 minus 6 is 7. And so what we're going to do is get the square root of 7 squared. And in order to draw this, the origin will be the opposite, negative 2 and 3. And the radius is going to be root 7. Root 7 is the same as 2.63. Now when we draw that, the origin or the middle of our circle, the center of our circle is going to be negative 2, 3. The negative 2, 3. It's going to be the center of our circle. And it's going to be 2.63. So it'll be a little more here. I'm sorry, it'll be a little less there. Be a little more there, there, there. Because that's the radius is 2.63, so all the way around. So to label it, you would do root 7 or 2.63. And then the origin there is negative 2, comma 3. That's how you draw a circle. You complete the square in order to graph or draw a circle. And in the final lesson is lesson 64. And in lesson 64 here, we're going to do this thing called CIS. It's to be C-I-S, and it stands for cosine imaginary sine. And basically it's cosine plus, it's plus or minus cosine, plus or minus sine, and then you'll have an I on the sine one. So when you're multiplying the CIS problems, you actually will multiply 5 times 7, which is 35, and then you'll add 280 and 300, which gives you 580. And you can subtract 360 or whatever, it doesn't matter, leave it as 580. In order to solve for this, you'll do 35 cosine 580 and 35 sine, that's an I, 580. We'll just remember to put an I on that. So you'll put that into your calculator. You'll put it in your calculator in order to take this from polar to rectangular. Now, in this particular problem, they actually don't even care for us to put it in rectangular. So our answer will be 35 CIS, and whatever 580 minus 360 is, it'll end up being 220. So this is the polar form of that multiplication. But if you wanted to go to rectangular, you would go in your calculator and you would do these two right here. In fact, we'll do one of those next. All right, in this one, we'll go ahead and multiply this out, and then we'll take it to rectangular form. This is in polar form. So 6 times 2 is 12, cis 3, 30, because you add those two, and you multiply those two, and you add those two. So 12 cosine 330, and then you 12 sine I 330. You don't have to put the I in the calculator, just remember that your answer is an I. When you multiply those out, you get 6 root 3 minus 6. So your answer is 6 root 3 minus 6i. Now, just to come back to this, when you put this in your calculator, you don't get 6 root 3 right off the bat. When you put 6 cosine 330 in your calculator, you get that 5.19 number. But you have to square that answer. When you square it, you get 27. Now, remember the 27 is not just 27, it's actually the square root of 27, and that's where you get, the square root of 27 is where you get that number of 5.19 whatever. So you got to break down the square root of 27. 3 is 9, 3 is 3. Remember, all of these are actually square root. So you take a pair out, and it's 3 root 3. So that is where we get, let me explain that again because I put the wrong numbers in. It's actually 12 cosine 330, but the same thing. You got 10.39. You square it, you get 108. But remember, it's not 108. It's actually root 108. When you break down 108, it's 2, 2, 3, 3, 3. So you get 2 times 3, which is your 6, root 3. And then this number was minus 6i. So that is your answer on how to multiply this out and then take it from polar, which is what it was in, to rectangular form. This right here is rectangular form.